Hey there. Welcome to a video where I'm going to show you how to use strategies for the SAT math section. And definitely DESMOS will be a big one we'll talk about. We'll also talk about how you could plug in numbers for variables or work backwards or anything else I think that might be helpful. So this is a practice I did a while ago. It was March 30th, 2025. If you actually click on my test, you'll see that I did fairly well on this test. Hold on. I don't know why I can't go back there. Hold on. Okay. Uh-oh. Okay, what is going on here? Oh, there we go. Okay, good. So yeah, obviously I got 790. That's really good. I did miss some questions though. I don't, maybe some on accident. I don't know. Um, but we're just gonna cycle through this. You'll see that the first math section was perfect, right? 1 through 22, perfect. The next one here, there were three questions that were missed and two that were omitted near the end. So let's go through this right now. So that was pretty easy. I'm not gonna talk about that one. That's pretty easy, pretty easy. Okay, here's an opportunity where you could use Desmos if you like. So you're given two equations, 4x equals 20 and negative 3x plus y equals negative 7. So obviously in the Blue Book app, as I've shown you already, well, don't want to do that. There's actually a button you click to pull up Desmos. So I'm actually going to just do it right here. Just going to do it as a separate browser. So 4x equals 20. And then the other equation was negative 3x plus y equals negative 7. Negative 3x plus y equals negative 7. So you get 5, 8. And they want the x plus y. Of course, that's 5 plus 8 is 13. So there you go. Probably you could do it algebraically, like x equals 5. You could substitute, not that bad, but you could do that. Um, let's see here. Yeah, here we could use Desmos again. Um, Let me hide the correct answers. So you could type in that equation. You could say, and absolute value, you could type in abs. Desmos knows that means absolute value equals 112. So then you have to figure out x equals. Now it's a little hard to figure out. So you're actually looking for x-intercepts. But what I would personally do whenever you have an equation that you're trying to solve, yikes, is let y equal that expression and then let y equal the other side. And you can always zoom out. I have a nice mouse here. And you get those two numbers. And what's the question asking for? The positive value of x minus 1. So I'm going to go 29. 29 minus 1 is 28. Hence, the answer is 28. There you go. So that's another option to use Desmos. Here's another one, another way. So here's a table, and they say it's linear, so it's a line. So if you actually were to type in table, the table pops up, and put in these values for x and y, so 10, 15, 20, 25. So 10, 15, 20, 25. Then for y, 82, 137, 82, 137, 192, and 247. So you see all these dots form a line. Then on the top left corner here, you see there's add regression. You could add any kind of regression. I mean, you could do quadratic, cubic, quartic. Obviously, we're going to do linear regression. And notice it gives you an equation right here, 11x minus 28. So that's the equation, 11x minus 28. So the slope is 11, and that's what the question is asking for. It's asking for a value of m. So it's totally going to be 11. Now, you could do this by hand too. It's not that hard. You could just find the slope between a couple points here, like 137 minus 82 over 15 minus 10, and just work it out. And you should get 11. So there you go. See other ways we use Desmos or strategies. This is a good way to use a strategy here. The population of A increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population was via K. So let's say the 2015 population was 100 people. So if you think about it, if you increase by 7% of 100 is 7. Any percentage of 100 is always the number itself. So then the question is the 26 population is K times. So 107 equals K times 100. What does K equal? 1.07. So that's strategy where you can make up numbers, and it's totally fine for percentages because it's all relative. You could use Desmos here. If you want no solution, that means you want the lines to never touch. I mean, I hope you can see it's C because they have the same slope, but if you wanted to, you could just do y equals 16x plus 3 and 16x plus 19. So I should zoom in a bit more. Yeah, you can see these lines don't touch. And so yeah, you could do that if you want. See if other options use Desmos. You could use Desmos here, I suppose. 9x minus 10y equals 19. You shift this graph 4 units down. What is the x-coordinate, the x-intercept of the resulting graph? Might be a little tricky using Desmos. I mean, I could type in the equation like it looks. 9x minus 10y. The x-intercept's right here. The y-intercept's right here. So we shifted 4 units down. I know what the new y-intercept will be negative 5.9, but it's kind of hard to tell. So I'm not sure if I really like doing it this way. I think what I would do personally is I would isolate y, get in the y equals mx plus b form, divide by negative 10, and then subtract that by 4 to get it down 4 units. And that's your new x-intercept, 6.555 repeating. And that's what we have is 6.556, or they would accept 6.555 repeating. You can also do as a fraction if you did it by hand, but plug in 0 for y and solve for x. But that's probably get y by itself and then take away 4 from the y-intercept to shift it 4 units down. That's what I would have done. Here's module 2. See if there's any good opportunities to use Desmos or the strategies. Ooh, that's a good one. So here they give you 2 points in a line. So again, I would go back to Desmos and make a table. Because you get the equation line, then I can actually plug in 4 for y and solve for x. So you can see cost is at 0, 7, and 8, 0. So 0, 7, 8, 0. Click in that left corner there, linear regression. There's your equation. If I plug in 4 for y, or I can graph y equals 4, by the way. And they touch right there. So 3.42857. Look at the choices. Obviously, these are all fractions, so I could use Desmos to calculate to see which one is going to be 3.42857. Like, for example, 7 over 2, I have to say equals. Oh, never mind. 7 over 2, 3.5. Nope. 24 over 7 was one of the other choices. Yep. So it's the third choice. 26 over 7 obviously would not make sense. That would be bigger. Or what's the other one? 27 over 8 does not make sense. Nope. What was it again? It was 24 over 7. There we go. Sweet. Okay. Um, yeah, same thing again. They say which of the following equations defines this table? Well, shoot, just go back here again, type in table, -1 and 10, 0, 14, 120. Now, very important, these equations are all quadratic because they have squares in them. So I don't want linear. It's going to give me linear initially. Switch that to quadratic. And there's your equation x squared plus 5x plus 14. So it's going to be D. And notice that there, look at this solution. It's crazy. Like, this is nuts. Why would you do this? This is absolutely insane. So this is why you have me. You have me to help you be more efficient. So yeah, Desmos to the rescue again, right? We're here, remember fx is y equals x plus 5 over 15, and f of a is y equals 10. What is a? So what is the x coordinate? Well, you can do it by hand if you want, or you could just do this. Y equals x plus 5. Shoot, I got to division first. X plus 5, 15, because my short-term memory sucks. Y equals 10. So you have 35 comma 10, and x is 35. Other opportunities to use Desmos. Yeah, if you want to find the slope, I mean, you can get y by itself. It's not hard. And you want to be perpendicular. I don't know. You can just do it by hand. That's geometry. That might be a little tough to do Desmos. I think here, this is a good one. So they say this equation has no real solutions. So what that means it's going to be whenever you have a quadratic equation with x squared, it's going to be a parabola that never touches the x-axis. When it's no real solutions. If it has one real solution, it would actually just graze the x-axis or just barely touch it. Or if it has two solutions, have two x-intercepts. But in our case here, we want no solution. So we never want to touch the x-axis, right? So no real solution. C is greater than n. Okay, well, that's kind of weird. C is the last number here. And they want C to be large enough so that it's not touching. So let's do that. So I'm going to say y equals x squared plus 34x plus c. Maybe it was minus 34x, okay? And you're gonna add a slider. Then what you're gonna do is gonna slide this until it's not touching the x-axis. So that doesn't help me. Looks like it's getting closer to being above the x-axis. So I'm gonna increase this to like maybe like 100 and then slide it. Okay, that's not really doing anything for me. What if I did thousands? Okay. So I definitely need to may consider say 500. Okay. So now I'm gonna slide this. Okay, so it's kind of hard to tell. So I'm gonna tighten this a little bit. Let's go from like 250 to 300. Okay. So see, it's missing it right now. It's totally missing it. So I gotta go back the other way. Okay, 289. Then when I do this, see it now it's below. So 289, I'm totally grazing the x-axis. There you go. So that means that C could be 289. So to guarantee that you get no real solution, that's going to have to be higher than 289, like 289.1 or whatever. So the bottom line is, in order to guarantee this, and actually n's going to be 289. But once you're higher than 289, so C would be larger than that to guarantee no solution. Sorry if that was a little confusing. But 289 will guarantee one solution, anything higher will guarantee no. And since C is bigger than n, therefore n's 289. So you can use that. There's an algebraic way of doing it as well, which is called the discriminant. But I don't want to get into that because that's more of an algebra 2 concept. Could probably do one more Desmos one. Actually, we'll do a couple more. So look at this one here. You have y equals negative 1.5 and y equals x squared plus 8x plus a. You want exactly one solution. So you're graphing a line with a parabola, and you want them to just graze each other like that. So you want one real solution. So what I'm going to do is graph y equals negative 1.5. And y equals x squared plus 8x plus a. Add the slider. So you want just to graze it. So I'm going to increase this up to 20, let's say. And I don't know why I did those colors. Switch that to a nicer color. They're better colors. Okay. So I'm going to keep sliding it until they just graze each other. And it looks like it's, yeah, see they miss. And they're right there. See 14.4, see it's below. So sometimes, you have to be a little bit sensitive here. But yeah, this is the way you could do it. Now, if you want to do this algebraically, which you'd have to set these two equations equal to each other, and you have to find something called the discriminant, which is the part underneath the quadratic formula, b squared minus 4ac, you might remember that, and that has to equal 0. I don't really want to go down that path. I think just use DESMOS, and that would be your best option. Then find for 20. Here's a circle. You haven't learned about equation of circles. In Algebra 2, they do it. I don't know if they do in geometry, perhaps. But this is a circle, and you can actually just type in the equation like the way it looks. You don't have to isolate y. In a graphing calculator, you would have to actually be impossible, I think, unless you know a technique called completing the square. By the way, it's a pretty wacky solution. So what you could do is you do x squared plus y squared, or sorry, plus x plus y squared. Well, it doesn't really matter, but I'll just do that. Plus y equals 192. Plus y equals 199 over 2. So here you go. You got these 2 points here. 9.5 and negative 10.5. So I'm doing that to find the high and low points in the circle. So it means that the diameter is 20. Those are the highest x and the highest and lowest points for y. You could also have done it, I think, for x, but I think it's easy to do it for y. So that's your diameter. So your radius is 10. The center, by the way, is going to be right in the middle. And you can find the midpoint, which is going to be, I think, negative 0.5, negative 0.5, negative 0.5 for x, and negative 0.5 for y, because you're doing the average of x and y coordinates. And yeah, looks like that they want the radius of 10. There you go. So if we think back here, how many times I used DESMOS to help me out, or some strategy? Okay, didn't really do it there. Didn't do it there. Didn't do it there. Didn't do it there. It did it here. So that was 1. Didn't do it here. 2, 3. Did some strategy. So 4, 5, 6, 7. No, I didn't do for that one. I could have, but we'll tackle. We'll say 7, 8, 9, 10. Could use some strategy here. We'll say 11, 12. I think use some strategy 13, 14. Yeah, I say about 15. Definitely that one, 16. Yeah. So you're looking at close to half the problems. You could use Desmos or some sort of strategy to help you out. So I hope you found this helpful. And we'll talk about strategy when we go over your tests on Monday. All right. Talk soon. Goodbye.